everybody, and welcome back to MLSecOps Connect, Ask the Experts. What you're about to watch is an on-demand recording of a live conversation we had on August 28th with Sean Morgan, who is Chief Architect at Protect AI. In this session, called ML Model Security, Is Your AI Protected?, Sean joined us to field questions from the community about security for AI and machine learning assets, including machine learning models, the importance of scanning your ML models, and how to get started with scanning them, including open source resources that you can use. We hope you enjoy. Let's jump into today's topic. Sean, before we get started with the many questions that were submitted by our community members watching today, do you mind sharing with them a bit about your professional background and what brought you to Protect AI?
Yeah, for sure. Hi everybody. My name is Sean. I'm the chief architect here at Protect AI. My experience, I used to work in the semiconductor industry, doing production machine learning, a lot of computer vision tasks, and actually moving those into production enterprise relied upon applications. After that, I did a stint doing adversarial machine learning research, so defenses specifically for adversarial machine learning. And then after that, I worked in the cloud infrastructure at AWS, helping customers with their machine learning and AI solutions. And then what led me over here to Protect AI. So it's been a wonderful year so far.
Fabulous. Thank you. All right. So diving in, topic for today's session, ML model security. Is your AI protected? So a lot of the questions that we received are about model scanning, machine
Mhm.
learning. A machine learning model for some of our early learners is an asset within your AI ML ecosystem. And we're going to talk a lot about where those are vulnerable, how to scan them, that type of thing today. So opening question, Sean. And I just realized I need to make a note here of who asked this question. I'll come back around to it. Props to somebody. What are some solutions for model scanning?
Yeah, great kind of lead off question here. So I think it's important that we just kind of level set with, why are we scanning the models in the first place? And then I'll be happy to talk about, what those solutions are that exist today. So with respect to the asset that you brought up there of a machine learning model, often these are kind of utilized either from shared foundational model hubs, where you can actually go and pull these kind of state of the art models, and you can fine tune them on your own data. That's one way in which we are, taking these binary artifacts from places within the world, whether that's shared repositories or internally within your company, and you're putting a good amount of trust into that object. Uh, at the end of the day, you're using it as a executable file, and with that comes a number of inherent risks. They could have the problem set of where you are, launching some embedded payload, whether that payload is, scooping up your credentials or making your network accessible to an adversary. Those are the type of things that you want to scan your models for to prevent that from happening. Um, so to the question of, what are the available solutions in this space, there's a number of things you can do. There are open source tools in this space. Protect AI publishes a open source project known as Model Scan, which will actually do a number of checks against these type of model formats and give you a bit of a report on how it goes. There are enterprise products that actually do, that type of scanning in a enterprise capability. At Protect AI, we have a product known as Guardian, where you're actually going to have this bit of policy enforcement and actually gating the models as they move through your environment or enter your perimeter based off of these kind of vulnerabilities that are found. And then the last thing that I kind of want to call out in this space is with respect to, there are models that you're pulling in and you want to make sure that they're safe, but you also want to understand like where you're getting them from. And so that's in a new and evolving space that we're seeing around, model attestation and verifiably proving who you are getting the model from, whether that's Meta or another organization that kind of publishes these state of the art models. So there's a lot going on in that space. If you look into the Open Source Security Foundation, or OSSF, there's an actual working project on this, and there's some GitHub repositories that we can share with respect to that too.
Yep, absolutely. And we will share links to all of these resources that Sean mentioned for sure. So you don't have to worry about furiously capturing them as he's talking for the session. And I got my ducks in a row. Shout out to Princeton security engineer for that question. Thank you, Princeton. Up next, Sean, this question from Surya, who is a founder at their company. How can enterprises protect their AI machine learning models from insider threats?
It's a great call out. So when we talk about shared model repositories, what we're talking about is kind of that outsider threat, like basically I'm pulling things into my environment. But it's not just that that's really the concern. There's this insider threat that someone within your organization could be putting these type of vulnerabilities into models that are going to production within your enterprise. That could be for a number of reasons. It could just be a nefarious actor. But it could also be, you may have a compromised system or a host in your environment so that, malicious adversaries are able to use your own, machines in order to, say, poison a model or something to that effect. So, what can an enterprise do to protect themselves from these type of threats, given that there are insider capabilities here too? And I think it's really important that we talk about zero trust in this space. And that is to say that no matter where the model came from, whether it's a trusted source that developed it or it's your own internal employee, you should still be scanning that model at every step of the process. So, like as models are trained and moved into model registries, and as models are moved into production deployment or testing, take a zero trust standpoint and scan that model every time as a gate to make sure that it is in fact the level of security that you expect prior for it going into any type of production systems.
Right. Thank you. All right. Up next, question from Rico. Rico, good to see you again. I remember you were with us last session, senior security consultant, very active member of the community. Much appreciated. Your question to Sean. In your opinion, which three design principles are the most important for secure AI infrastructures?
Yeah. So I'll just continue kind of where we left off on the last question within zero trust and say that that is one of them. And that is, to say, borrowing kind of a term from the general cybersecurity world, is that it is safer to take a stance where you don't rely or trust upon, where you're getting things from or how they're working, and instead that you actually verify it. And so, with respect to model security, and one of the, a key principle there, zero trust and taking that approach to how you utilize these type of assets is one of the kind of key principles that I would call out there. Um, a second one I would say is this concept of shift left, also from the cybersecurity domain, which is to say build security into every step of your process. So don't wait until the models have been developed, the internal machine learning developing teams have created them, and at the very end we stitch on some AppSec at the end that we make sure that everything's okay and we call it good. And instead, with shift left, what you're doing is you're moving security to the various stages of development. And so that could be everything from the machine learning developers that are looking at the data sets and ensuring that they are safe to use or are coming from reliable places. It could be the developers that are utilizing secrets and other information as they access the resources they need to create the models. Everybody within the enterprise should be aware of the safety and security threats, so that they can protect themselves from them and ultimately protect the enterprise and the production outputs. So yeah, shift left, I would say, to make sure that it's responsibility of everybody to be secure. Um, and then a third guiding design principle, I would say, is around transparent policy enforcement. And so when I say that, what I mean is the AppSec teams or the security teams that come up with the governance or the requirements for your organization, it should be very transparent to the end users. It should be clear what the expectations are and how they're set and evaluated, so that you can build that into the process. So I would say that those three design principles, within respect to don't take anything for granted. Make sure that you take zero trust and scan throughout your process. Shift left so that the actual developers are there, taking ownership of security and the responsibility of that, and then transparently creating and sharing the policies within your organization to make sure that you're able to achieve them and everybody knows what is expected.
Fantastic. I'd like to add a point and a resource about the comment you made related to shift left and kind of the practice of building security into every aspect of the life cycle or all those processes. There's a wonderful resource at MLSecOps.com when it's in an article about what is MLSecOps and a short snack bite of a video there where Diana Kelly walks us through the different phases of the machine learning life cycle, and it shows the different phases that Sean mentioned, including clear back to one of the very beginning phases, like data prep, and some examples of security practices that you can do or build into your traditional ML ops workflows that are tied into DevSecOps principles. So that's another resource that you can refer to as well to build on what Sean just shared. All right. Next question from machine learning engineer Stan. Thank you so much for the question. What are some of the security threats we can't use automated scans for?
Good question. Definitely something to kind of contemplate there. I would say that there is a lot of academic research in certain areas of uh, model security and machine learning that we have yet to really solve the problem and have a clear, viable way to scan for those type of threats. Specifically, what I'm thinking of is poisoned weights. And what that means is essentially if you have a machine learning model, and we call that like a set of parameters within the model that ultimately makes some decision, whether that's a classification or what have you, there are ways in which an adversary could take those parameters within the model and edit them. They could edit them in a certain way that, with the right trigger, with the right input to the model, they could get a predetermined outcome. And so one of the kind of goals you would have within AI security is, hey, if I just take a machine learning model itself, can I look at those parameters and say someone has poisoned this particular model? Um, that is a very, very difficult thing to do when we're talking about models that have, trillions of parameters or billions of parameters at least. And so the complicated ways of doing that in an automated scanning method are truthfully a very difficult problem to solve. What you can do though is look at the supply chain that went into the model, as well as who or whom you got the model from. So a bit of a callback to that model attestation standpoint here. If you can attest who created the model and you have some level of ability to validate that it was truly created by them, that they can attest to maybe a bill of materials of what data went into the model. You can kind of work backwards into saying that this is a threat that you think is unlikely, that there's been poison weights within the model. So that's the one that comes to mind first and foremost of something that there's not quite an automated solution for it yet, but there is that built-in best practices and shift left aspects that you can use to kind of reduce the risk there.
Okay. That was a fantastic question. All right. This one's kind of personal, Sean. Another one from Rico. Which resources do you use to advance your knowledge in the context of AI security?
Interesting. A few things come to mind. Uh, I like to watch videos whenever I can. I like to see visual aids, so I do use YouTube. There are a number of conferences that end up posting their talks on there. So B-Sides comes to mind as some of the recent talks being posted up recently. But I tend to look for recent conference talks on AI security that are published to YouTube that I can kind of review. You can pause and kind of validate claims or look at other aspects of where that's coming from. Um, Academic research is a common aspect of this field. It's um, uh, research comes out on a regular cadence. This is, like I mentioned before, there's a lot of unsolved problems in this space. And so keeping up with that academic research is challenging. There are tools that you can use to kind of subscribe to certain, researching organizations. But I find using, Twitter or X to be the best way for me to kind of pull in that information. I'm able to see, what are people talking about with respect to recent research, and then prioritizing that on my list of things to read because, there's no shortage of things that we all would love to read or watch in the day. And I think it's very important that you're able to kind of prioritize what you want to look at there, with respect to what you have the availability to do. Lastly, I'd kind of call out instead of Twitter or X, there are Mastodon, kind of distributed communities in this space. InfoSec Exchange comes to mind, where you can kind of find groupings of people that are interested in similar topics, see where the conversation leads you, and then keep up to date with those research that is being built. So yeah,
Yep.
I'd say those are the uses.
Awesome. I love X as well. If you can manage to find a group of experts that you can follow, they're really good at distilling some of like the academic research that you talked about. Videos are also great. Coincidentally, just today within the MLSecOps community, both in Slack and our Learning Hub, community.mlsecops.com, in the general discussions forum, we did just post a list that was borrowed from the authors of TLDRSec, who did a great job of creating an aggregate list of over 60 talks that were given at B-Sides Las Vegas, Black Hat, and DEF CON earlier this month, all related to AI. And there are some there's an AI security track and AI attacks track. So go check that out. Awesome. Okay, moving on. An additional question from Rico. This might be the last one. Thank you for all of the awesome questions. How would you design, Sean, a zero trust approach for the current LLM architectures, large language model architectures?
Yeah. Okay. So I think to start, I'd kind of break the question down into, where do you get your large language model from? And to me, there's kind of two primary camps. There's the shared model repositories, whether that be, Hugging Face or Kaggle, where you may actually be pulling down these foundational models and either running them yourself or fine tuning them and then running them.
Sure.
So that's one aspect of where the LLMs are coming from. Alternatively, is the API endpoints, the Open AIs and Anthropics, other places where you can get access to these large language models. So from a zero trust standpoint, I think that it's important that you do kind of two things. One is if you are pulling down the actual model artifacts themselves, the files from the shared model repositories, that you're doing what we talked about with respect to scanning them. Taking that zero trust, even if it's coming from an organization that you know of, still scan that because there's the risk of compromise or some kind of ability for someone to have affected that even internally in those trusted organizations. So from a zero trust standpoint, scan the models. But then after that, once you're either running the model or you're using an API endpoint, there's tooling you can do in order to kind of automatically red team the model. And from a zero trust standpoint, what you're saying is that you know these organizations have validated complicated system prompts and other types of guardrails that they've put into place, but you should still validate that the risk that your particular organization is concerned about is alleviated or at least protected against. And so for that, there's open source red teaming tools that you can find on GitHub, as well as enterprise products like the recent our company recently did an acquisition for a product that will be known as Recon, which is about using automated red teaming tools in order to kind of probe these large language models for risks to either security within prompt injection or safety with respect to like jailbreaking them or other options.
Great. Thank you so much.
Mhm.
All right. Next question is from community member James, who is a solutions architect. Thank you for the question, James. How would you suggest aligning best practices and standards in a palatable, won't slow down the business way? And this is a big concern. We've heard folks talking about this within the community before.
Yeah, and truthfully, one of the reasons why security in the AI space is, I guess you could say lagging or we're playing a bit of catch up, is because the pace of innovation in AI and machine learning is so fast. The new state of the art models come out so regularly that there is this kind of ongoing need to move fast and to make sure that you're keeping up with the business needs of trying to get AI and machine learning into these production use cases, using the most state of the art model as kind of your foundational building blocks, and so speed is important. And I think that this question kind of keenly calls out that how can we go about building this secure AI enterprise or enterprise that uses AI in a way that doesn't slow down that development? And so there's a couple of different ways in which you can orchestrate this. But one technique that we've kind of really seen is that anywhere the security teams or the AppSec teams or whoever is owning the security of AI and machine learning can instrument these type of checks in a way that doesn't get in the way of the typical process is kind of the ideal goal there. And I'll give some concrete examples of that. So, for example, if you have defined pipelines or CI/CD flows that you have established within your organization, like if you want to move a model from development into production, like this is the process. We do these, various checks, and that's a generally a common practice. It's within those promotion pipelines that you should be instrumenting the security checks. And this can be done in a templated way. You can have like a defined way in which this happens, and so that the developers of the machine learning models don't need to have to constantly be thinking about I need to make sure that I scan this model. Instead, they can think I need to make sure that I use my approved templated pipeline, which will scan the models, and they can own that as well. Um, Additionally, when you go to pull models from these type of shared model repositories, if you can, intercept that type of traffic and actually validate that the models that are getting pulled are secure, that would be a great step in the process. And one of the products here at Protect AI within Guardian is about doing that with a gateway where we can actually have an administrator, set up these type of a proxy, if you will, that will intercept traffic to these shared model repositories. It will perform the scan and the policy evaluation without the model developer ever really needing to know that that's happening behind the scenes. So abstracting away where possible, or at least incorporating it into the workflows that already exist is a key aspect of that.
Got it. Thank you.
Mhm.
Wanted to pause quickly to note we're receiving several questions with asking for more specifics in the chat. I do see those coming in. We've got several more to get through that were sent along during registration, so we'll get to as many as we can. But in the event that we don't get to your question from the chat today, I'll be collecting additional commentary from Sean that we will share after in the show notes. So
Gladly.
no worries there, including more specific examples. Okay, this next question is from Director Aaron. And I think the way that it's written, it's referring to probably some more Protect AI tooling. Aaron asks, do you provide both red teaming and guardrails for LLMs?
Yeah, interesting. So,
We've touched on this a little bit,
yeah,
but yeah.
yeah. So this has kind of been brought up in a little bit, but I'll go into some more depth. We do, and the reason for that is I'll go through two aspects. We'll start with the red teaming. One place that we find a number of customers is in this space where there's often either a directive to get these AI systems into place, or clear burning needs to have them move to production, but there's kind of a known risk that will happen when they do that. These types of jailbreak attacks and even prompt injection and things are so prevalently known. It is more or less made it into the common understanding of people that use these tools that, like, hey, there are ways that I can convince the LLM to, like, for example, give me the directions to create napalm or something along those lines. Like you can trick it into giving a very dangerous output, which often comes with reputational harm for enterprises that are doing this. And so you're at this spot where, like, we know we want this product, we know we want to launch this, but are we really able to do it? And that's where red teaming comes into play. And so you can use these type of red teaming tools to gauge your risk if you move this application into production, and not only gauge the risk of moving the application as it is, but also, let's say we add guardrails. Let's say we add some component of blue teaming around securing this model. That's where you can again use the red teaming tool as a gauge of what level of security you find comfortable to move these type of things into production. And for that reason, yeah, red teaming is an offering within our product suite, as well as a blue teaming or safety and security of the guardrails around the product. So at Protect AI, we have an open source tool known as LLM Guard, very popular way of kind of firewalling these prompts and outputs from an application. We have an upcoming product that'll be the enterprise controls around this space, and that'll be known as layer. So that's not actively published right now, but it should be around Q4 this year. So to answer the question, does Protect AI cover this space? We have an active red teaming product and a LLM security product that's launching later this year.
Super exciting.
Yeah, absolutely.
Yeah, can't
Really
wait
fits
to share more about that.
the full platform there. So exciting.
Yes. All right, diving into some specifics. Daniel, who is a university professor, wants to know about attacks. So, kind of a three-part question here, and I'm going to read each part, and then if you need me to go back to repeat anything,
Sounds
I
good.
can do that. But opening with, what type of attacks does your model scanning tool cover? And again, I'm assuming Protect AI is the reference here. And are the attacks domain specific? Example given, attacks on text versus image or generic.
Mhm.
And the third part is, once the model vulnerabilities are detected, what defenses do you have?
Okay. Yeah, so I probably
It's
will
a
need you
meaty
to
one.
to
Yeah.
to, to, to
Yeah.
walk
So
me through the bullets.
starting off, what types of attacks does it cover?
Yeah, so there are several types of attacks that we scan for, both within open source and commercial products as well. And some of those are related to payloading of the model, or basically including other, code instructions that will be ran at some point in the usage of the model. So specifically, that could be whether you are loading the model or opening it for the first time. There's the ability for some bit of code to be executed in the background. It could be when you are actually running the model. And so you can actually embed uh, executable code within aspects of the model so that if you use the model, some bit of code will be ran. Um, those are some of the threats around, we call them serialization attacks, basically using the way in which you save and load models in order to run some type of attack vector. Other threats that we detect is we actually inspect the machine learning model architectures themselves, looking for components that are either abnormal or just outright malicious. And so an example of this could be, there are operators within some of the machine learning frameworks that facilitate you communicating between two servers. There's a good reason to have this. If you're using some sort of distributed training process, you need to communicate, updates to the model between different servers. But what we've found is you can also utilize that same operator within a trained model, so that every time you're using the model, you're actually calling out to some external server and maybe passing them information about what type of data is going to the model or something else nefarious. So we also inspect the actual components of the model to see what's being used, and if this is something that your organization is aware of, or if this is just outright reaching out to some external source. Um, and then another type of attack vector that we investigate for is backdoors, which is similar to what I talked about earlier around like poison weights, whereas a specific trigger, a specific input to the model will have a predetermined output that you can kind of coerce. But what we're specifically looking for with these backdoors are architectural backdoors. So we're looking for separate pathways within the model that can be taken if a trigger is presented. So one example that we kind of often give to kind of clarify that is, if you have a credit card, fraud detection model, you can backdoor that model so that anytime a particular zip code is used on a transaction, it will automatically be classified as not fraudulent. And so that's another attack vector that we're looking for. So to kind of summarize there, backdoors, misused operators or operations within the model itself, as well as this kind of embedded code or embedded payload within several different aspects of how the model's packaged are all some of those threats.
Okay. And so some of the attacks or threats that you were discussing just now, second part of that question, would you describe those as domain specific or more generic?
Yeah, so they are generic in general. We tried not to get too closely tied to specific modalities, whether it's images or text, because ultimately there's a lot of commonalities in like how the model is loaded. Doesn't necessarily matter what type of model it is. Uh, the operator that I kind of mentioned with respect to making external calls could be embedded into any type of model there. So in general, we're looking for generic attack vectors. The back doors, for example, look different for a kind of classical numerical model, or something that's using images, or something that's using NLP or text. But ultimately, we're looking for those back doors in whatever way they manifest. So.
Got it.
Mhm.
Okay, and the final part of that question from Daniel, awesome question, thank you, was once those attacks or threats, vulnerabilities are detected, what defenses do you have or suggestions for mitigation, perhaps?
Yeah. So for many of these, I'd say the majority of it, if you're looking at a model and you're finding that there is a payloaded code that's going to be ran, let's say that some of the things we've seen in the wild are that, like, it may scoop up the credentials on your system and push it to a server. It may reach out to an external endpoint and, like, actually download a binary artifact and run it. We've seen that as well. If you're finding those type of vulnerabilities in your models, there isn't a fix for it per se. It's more of a post-mortem. It's about finding out, how did this model enter our perimeter? How did we end up, trying to use this in production? And so you can think of it a bit like a malware scanner, an antivirus tool. If you find a virus, you typically, may not want to, like, try to fix that file. It's more about, like, where did that file come from? And how do we prevent that from happening again, as well as quarantine it and remove it from production.
Great. Thanks again for the question, Daniel. Okay, I'm doing a time check here, Sean. I think we have time for three more questions. This last one, I think, helps us put a nice bow on the model security topic. And then I have two that are a little bit outside of what we've been discussing today, still somewhat related, but I think they'll be fun to ask you
Sure.
while I have you here,
Mhm.
captive. All right, so this question is from Rahul, Deputy VP. How can we, and you've spoken a little bit about this, how can we follow a shift left approach for model security? Just broadly speaking,
Yeah.
your recommendation.
Yeah. I think it starts with education. And so one of the great things about MLSecOps.com and the community there within podcasts and educational training material is, it's impossible to shift left and kind of move ownership to the developers of security and make sure that everybody is responsible for it without them really knowing what the problems are. So I think, a key foundation to being able to do this is to educate your teams or your colleagues on what the problems are, why this is both unique threats, but also similar threats to some of the other things we see with, if I'm going to go download a file from the internet, what are some of the concerns that can happen, and making sure that that is clear as to how it also affects the machine learning or AI model development lifecycle. So yeah, other than the tooling and everything we've talked about with ways to shift left, I think it starts with education and facilitating that knowledge to the team. And then from there, it's about implementing those tools and making it so that it's not a burden, and that it can be integrated into these kind of pipelines that you have templated or defined, or intercepting traffic to shared model repositories and checking it for them without them actively having to keep that in their mind space as they're developing.
Well said. 100% agree. And thank you for the MLSecOps community plug. Always love that. Okay, bonus question round. This is from Gennady, who is a senior manager. What is the importance of open source data set scanning for malware? So, broadening things a little bit. And what are some scanning tools for data sets?
Yeah, it's actually a more challenging question than it may appear on the surface. So when we're talking about data sets for these AI machine learning models, they can be up to petabytes in size, and so you often run into this kind of scaling challenge where, if you're scanning internal data sets that are could be petabytes in size, or terabytes in more public data sets, or gigabytes there, hundreds of gigs. It's not easy to just simply scan over them and find some of these problems, especially nuanced problems like misinformation or other aspects in that space. You can scan them for malware, for example, but typically these files will be broken up into shards, or several different files when they get to that certain amount of scale. So you can use, open source tooling. Even if you look at repositories like Hugging Face and things like that, they use ClamAV, kind of open source malware scanning, to validate that data sets aren't, overtly malicious, that the maybe binary files, if it's like a Parquet file or something, isn't just a piece of malware. But there's a lot of nuance there into, like, what the data can be affected by. And I think, not to give a cop out answer here, but I think it's something that the community at large needs to continue to develop solutions on. I don't think there's an easy answer to just say, use this tool, scan your data sets, and you're good to go, because of the scale problem, but also the nuance in, like, what is a bad data set, and how can you prevent that from being used.
Thank you. All right. Last question. Again, calling out to the chat, Baveen, Marcus, Anna. I see your questions. We will get commentary for those and they'll be posted later. So thank you so much for participating. This last one is a juicy one for you. How would you design current defense mechanisms against rag poisoning? And maybe for folks hearing that term rag for the first time, just a little bit of context.
Yeah, for sure. So when we talk about RAG, what we're referring to is retrieval augmented generation. And so what these are typically, the pattern is you have some large language model that you want to ask questions to, and that large language model or that application needs to tap into a data source of some bit of information so that it can augment its answers with the correct bits of information. So in an enterprise, that could be tapping into your internal documentation. It could be tapping into, say, like the employee, HR database or something along those lines. And so the process there is often, using some bit of a way of embedding what the information that you need, and so that it can be retrieved easily, and added to the process. When it comes to rag poisoning, there's a number of ways in which that can kind of manifest. You can have it so that the initial, or the data that's been uploaded to that vector database has been already poisoned, um, as well as, making it so that often these data stores will be continuously updated, and so that there can be changes to that initial data store of information. So when architecting a way to prevent that type of rag poisoning, I think the kind of architectural patterns that I think you'd want to put in place is around validating the process of embedding and loading these stores, making sure that these are, trusted information, and that it comes from, if it's internally, a space where there was restricted access patterns, and you could actually have controls around who was able to update that data. And then as it progresses into production, I would say, the observability around your data stores and who is accessing them, what ultimately the end users are that are using the LLM application to access the data store. Having that observability into that chain of usage is critical into kind of monitoring and preventing, real time types of poisoning. So yeah, I think that it's a complicated problem for sure, but it's something that I think we'll see continued to be built out in this space of AI security.
Excellent. Okay, thank you. Well, we are at time. Sean, it was really a treat having you join us here in the studio today. Um, for those of you, if you have follow-up questions, you can reach out to me. You can also reach out to Sean. He is in the MLSecOps community. You can join a couple of ways, either by going to mlsecops.com/Slack, if the Slack space is more your thing, or creating a profile at the Learning Hub where you can search our list of resources and find more content like this. And that is, again, community.mlsecops.com. Hope to see you again at another MLSecOps Connect session. And until next time, that's a wrap.
All right. Thank you, Charlie. Thanks for having me on.
Thank you.